Hi everybody, it's Mrs. Dunn. So we're going to talk about linear functions, slope, and applications in this screencast. So specifically what you should learn is how to determine the slope of a line given 2 points. You'll do that both from a graph and from just the points. You're going to find the slope and the y-intercept of a line from an equation and from a graph. And you're going to graph a line using the slope and y-intercept. So let's get started. So does this equation look familiar? This is the standard form of a linear function. You might remember this as slope-intercept form. But any equation that can be written in this form as a function is an example of a linear function. Sometimes it's written with the function notation f of x equals mx plus b, and sometimes it's written as y equals mx plus b. So what we want to do is specifically talk about when m is equal to 0. When that happens, what we have is a constant function. So let's look at an example. So for example, if f of x is equal to 3, look at what the graph of that looks like. You can do it on your calculator, typing in y equals 3, and we see we have a straight line, and you can think of it as y is constantly 3. So that's why we call that a constant function. In this example, the slope is equal to 0. That's when m is equal to 0. Now, let's talk about horizontal lines and vertical lines. So this was an example of a horizontal line. Now let's talk about vertical lines. So the equation of a horizontal line is f of x equals b. That was the previous example. Now the equation of a vertical line, which is not a function, is x equals a. For example, if x is equal to 4, what does the graph of x equals 4 look like? Well, x equals 4 is a straight line, and it's a straight line that goes through when x is equal to 4. It's a vertical line. Why is this not a function? Well, it's not a function because it doesn't pass that vertical line test. It basically is a vertical line. Okay, so we want to talk about slope. In the previous example, let me go back to there. The slope here is 0. We're going to talk about this in more detail. And the slope of our vertical line does not exist. So let's talk about why. The definition of slope. There's a lot of ways that you can think about it. The slope of a line containing these 2 points is given by this equation, y2 minus y1 over x2 minus x1. Now, where that comes from, it is the change in y over the change in x. You're going to learn a lot about that if the next class you take is calculus. You're going to be doing a lot with the change in y and change in x. Basically, that's differentiation. Sometimes people also describe it as the rise over the run. So if you have 2 points, if this is our first point, if we're going to talk about the slope of the line containing these 2 points, we're talking about how much we have to go up or down and how much we have to go left or right to get to the next point. Let's look at another example. Consider the function f of x is equal to negative 2/3 x plus 1. Graph that function. We're going to graph it the way we learned it before by using the x and the y-intercepts, or we could do it by using 2 arbitrary points. So I'm going to use the second option and find the equation of this line using 2 arbitrary points. So what I want you to do is plug 3 into this function and plug 9 into the function and find those function values. Pause the video if you want. Did you get -1 and -5? Those are the 2 function values. So now we have ordered pairs. We have the ordered pair 3, -1 and 9, -5. So when you graph that on your graph, so here's 3, -1, and here's 9, -5, then we could do that rise over run. So to get from this point, 3, -1, to the second point, I have to go down 4. So the rise is -4. The run is 6. So the slope of this line, M, is -4 rise over 6, which is the run. So the slope is -2/3. Hey, doesn't that look familiar? So you see how the M value in our function is the slope. So when we have a linear function in standard form, the slope is going to be equal to M, and the y-intercept is going to be equal to B. Okay, so let's real quickly go through 4 examples. So I want you to pause the screencast and, using that definition, find the slope of these 4 lines. 2 are written in function notation and 2 are written just in the standard equation format. So did you get, in the first example, the slope is equal to 1.3. In the second example, the slope is equal to 5. This is a constant function, so the slope is equal to 0. And this is the equation of a vertical line, so the slope is undefined. All right, perfect. Now, what we're going to do next is find the slope containing 2 points. So, for example, find the slope of the line between these 2 points. You can use the rise over run. Did you get 6/5? So you have to go up 6 and over 5. All right, one more example here. What about the slope of this line? This is a vertical line, so what's the slope? Hopefully you said it's undefined. All right, excellent. So now what we want to do is find the slope of the line containing 2 given points. Now, we could graph these points and then do the rise over run and count, but we can also use the formula. So I want to talk about using the formula right now. So the formula, remember, is y2 minus y1 over x2 minus x1, rise over run. So you want to plug these values into there. So the y values are, so when you put the numbers in the formula, you should have had y2, -13, minus y1, which is -1, and x2, which is 2, minus x1, which is -6. So -13 minus -1 over 2 minus -6. And when we simplify that, we get -12 on the top and a +8 on the bottom. And so that slope is, when you divide the top and the bottom by 4, the slope is -3/2. All right, so that's how it works when you're given 2 points. The last thing I want to do with you here today is graph the equation using the slope and y-intercept. Now, before we were using 2 points, or we were using the x and the y-intercepts. So now what we're going to do is use the slope and the y-intercept. So what is the slope and the y-intercept for this equation? Well, the slope is -1/3 and the y-intercept is -4. So to graph this, the first thing we're going to do is graph the y-intercept, which is -4, draw a dot there, and then use the slope, go down 1 and over 3. So from -4, we're going to go down 1 and over 3 and draw the next dot. That's the same as going up 1 and to the left 3, as long as one of those movements is negative. Okay, that's all there is for this section. I hope you're doing well. Please email me if you have any questions whatsoever. Good luck.